1665. Minimum initial energy to finish tasks. So let's first try to understand the problem. So we are given a task. At each side of tasks, it's gonna be subarray. So this subarray means tasks I means actual I and minimum I. Yeah, so this means initially we have some energy, and then for this energy, if it is more than the minimum, so for example, our initial energy, for example, we only have 1 and 2. Our initial energy is 2, so it means we can finish this task. So what left behind is 2 minus 1. It means we still have 1 energy left. Yeah. Let's just use this example, try to understand the problem first, and then I'm gonna find a approach to solve this problem. Yeah. So we are given a task like this. So we just imagine if we have a result like 8, what are we gonna do? So we're gonna choose one by one. Yeah, so for example, if we choose the third task, it is more than or equal to 8, and then we can use 8 minus 4, because 4 is the actual, and 8 is the minimum. So this 8 means we should have a minimum energy should be more than or equal to 8, and then we're gonna execute this task. And after executing the task, what left behind is 4. This is our energy. And then we're going to use this 4 to check. If this 4 is more than or equal to the second task, it is 4. So we can execute this task. So after executing the task, what the energy left behind? It is 4 minus 2. It is 2. Now we're going to execute this first task. It is this one, 1 and 2. So 2 is more than or equal to 2. So 2 minus 1, it is 1. Now we finished all the tasks, and our initial energy is 8, and 8 is the minimum, and it cannot be bigger. Yeah. But how can we solve the problem? And which tasks should be executed first? Is that according to the increasing order of the actual value, or is it the increasing order as the minimum value? Yeah, if we check the examples, it is not like that. So for this kind of a problem, we have to analyze what kind of a strategy we can use to solve this problem. Yeah. Now let's just analyze something. So for any two tasks, so for example, I'm going to use 3 and 7 as my first task, and 5 and 8 as my second task. I'm going to compare which task I'm going to execute first to get a minimum energy. Yeah, to get a minimum initial energy. So I'm gonna use some generalization to represent the problem. Yeah. So I'm gonna define the first tasks as task 1. It's gonna be A1, actual 1, and minimum 1, A1 and M1. And similarly for task 2, I'm gonna define it as A2 and M2. So currently, I can decide whether I can execute the first task or I can execute the second task first. So, for example, if I execute the first task and then the second task, I will represent it using T12. So this means I will execute the first task and then the second task. So T12 should be the maximum of M1 and A1 plus M2. Why? Yeah, so for example, so this A1 plus M2 means, for example, if we execute the task 1 first, yeah, we get a result of A1. This is our initial energy. For example, A1 equals to M1. Yeah, we're gonna get a A1. And after that, we're gonna what energy should we have to execute the task 2? At least we should have M2 energy. So it is A1 plus M2. Or if this M1, if this minimum is really big, so we're gonna just use this M1 is enough to execute 2 tasks. Yeah. Let's just use the numbers as example. So for example, if we execute 1 first, so for the first task, we're gonna what energy we use? So we need a minimum of 3 energy, right? So A1 is 3, and then for execute the task 2, we're gonna what energy we need? We need 8. So 3 plus 8, it is 11. So A1 plus M2, it is 11. Yeah, so for 11, after executing the first task, what left behind? It is 8, and 8 is enough to execute the second task. So this is A1 plus M2. If this 7 is really big, it is 17. So what is it gonna be? So if it is 17, our initial energy have to be 17, because if it is less than 17, we can never do it. So if we choose 17, after execute the first task, what left behind? It is 14, and 14 is bigger than 8, so it is enough to execute the second task. So this 17 is enough. So the final value is 17. It is M1. So this is why we can get this kind of a formula if we execute task 1 first and then task 2. So it's gonna be the maximum of M1 and A1 plus M2. Yeah. And similarly, if we execute T2 task, if we execute T2, the task 2 first, this one first, and then we're gonna execute the task 1, what is it gonna be? We just change this formula. Yeah, because here is M1, A1 plus M2, and here should be M2, A2 plus M1. Yeah, I think if it comes to mathematical formula, you have to think about it carefully. Yeah, to find a solution. If T21, if it is T21, so this M2 can be a maximum value, or this A2 should plus this M1. Now we are going to guess what kind of a formula we can get to prove whether we're gonna execute task 1 first or task 2 first. Yeah, because inside here, as you can see, it is A1 plus M2, and here is A2 plus M1. Now we are going to get the formula. Inside the formula, there will be A1 plus M2, and how can we make it? Of course, we can use M1 plus A1, because M1 plus A1 and M2 plus A2. So we can check. We're gonna check if M1 minus A1 is more than M2 minus A2. What is it gonna be? Yeah, so this example is like 7 minus 3, it is 4. 4 is more than 8 minus 5, 3. 4 is more than 3. What is it gonna be? Whether we will execute task 1 first, or we should execute task 2. So we're gonna guess if this M1 minus A1 is more than M2 minus A2. So we can get a formula A1 plus M2. So A1 goes here, and should less than A2. A2 goes here plus M1. So this formula actually is what we get. As you can see, A1 plus M2 is inside the task 1, 2, and A2 plus M1 is inside the task 2, 1. Yeah. Now we get this formula. Now we are going to check the value to prove. Yeah, we have to check the value if M1 more than M2 or M1 less than M2. What is the result? So let's just check M1 more than M2 first. So T21 should be equal to A2 plus M1. So this is the T21, and the T21 should be maximum of the two. So here T21, I'm gonna use A2 plus M1. So A2 plus M1 is more than, from here, A2 plus M1 is more than A1 plus M2. Yeah, and A2 plus M1 is more than M1, because this is M1 and this is M1. Yeah, so M1 and A1 plus M2, the maximum value is still T12. So this means T21 must be more than T12. Yeah, here we just guess T2 plus M1 would be the maximum value of T21. So this means T21 is more than T12. And what is our conditions? So our conditions is M1 minus A1 more than M2 minus A2. But what is the result? The result is T21 more than T12. This means T21 is a bigger value, but T12 is a smaller value. So this means the difference of the second value minus with the first value. If it is bigger, we're gonna always choose this array first. So T12 is smaller. We're gonna always choose T12 first. Yeah. Now let's check the second condition. if m1 is less than m2. So we're gonna check t12. So t12 is a1 plus m2. It is here, and it should be less than a2 plus m1, and it is here, a1, and for this formula, a1 plus m2 less than a2 plus m1, and a1 plus m2 should more than m2, because here, as you can see, m2 is the same. Yeah, so this means a1 plus m2 less than a2 plus m1 and more than m2. Yeah, but for the maximum value, this t12 should be less than t21, because for t21 it always chooses the maximum value. It is this one, a2 plus m1. So this is t21. Yeah, so this means t12 is still less than t21, and here t12 also less than t21. So this means no matter m1 more than m2 or m1 less than m2, we can always get the result. So t12 gonna be the minimum value. So according to our provement, so for any of the elements inside the tasks, we're gonna check the difference of the two elements inside the array. If the second element minus the first element have a bigger value, for example, this is 4, 8 minus 4, it is 4, we're gonna always choose this task first, and then we're gonna choose 4 minus 2 because the difference is 2, and then we're gonna choose 2 minus 1 because the difference is 1. So according to this, we can get our result. Yeah, now let's just start coding. So what kind of solution we're gonna use? There are gonna be two solutions, but for simplicity, I'm gonna use a binary search, because for binary search, if I can guess an answer, for example, if I guess the answer 8, I just need to use this 8 to minus every task, and then get the result to guess if it is true or false. Yeah. Now let me just start coding. Yeah. So the magic function is here. We need to use a sort, and this sort is the provement of these areas. If you can prove like that, and you can just sort the tasks. Yeah, you can use tasks dot sort. So inside the sort, we can use a lambda function. So we're gonna use a lambda function x is the element. So it's gonna be the x0 minus x1. Why? Because we're gonna check the always be the maximum 8 minus 4. But if we want to get the maximum first, we have to use the first value minus the second value. It's gonna be a negative value. If it is a negative value after sorting, this minus 4 will always be the first. So this means 4 and 8 will be sorted at the first place. So we're gonna use x0 minus x1. Yeah, otherwise you have to use x1 minus x0 and then reverse. So here I'm gonna use x0 minus x1. Now we can use binary search. So for binary search, let's prepare the template. So for me, I'm gonna use L, R, and result. So for L, it is 0, R, it is 10 to the power of 9, and result is 0. And this R is dependent on that, because the value minimum and actual is 10 to the power of 4, and the length of the array is 10 to the power of 5. So 10 to the power of 5 times 10 to the power of 4, it is 10 to the power of 9. It could be the maximum value. Now I'm gonna use the binary search template. Yeah. So the m should be equal to L plus R minus L divided by 2. And if it is possible, yeah, if this is possible, maybe there would be a smaller value. I'm gonna have a record of this m, and this R should equal to m minus 1, because I'm gonna guess a smaller value. If it is not possible, yeah, the L should be m plus 1. I'm gonna guess a bigger value. After that, I'm gonna return the result. Yeah. Now I'm gonna finish the check function. I'm gonna finish it here. Yeah. So the check function inside this m, I'm gonna give it a threshold. Now I just need to loop through the tasks array. Yeah, because this task array has already been sorted according to my provement. Yeah. Now I just need to check it one by one. So for yeah, let me check what is the variable actual and minimum. Yeah, so for actual and minimum in tasks, if this threshold is a bigger value, big enough, minus m. Yeah, maybe you're gonna guess, if we guess a value, why it is always works? Because we've already sorted the tasks according to our improvement. It means it always works if we find a value. This binary search, if we find a value 8, according to our greedy solutions, it should always work because we always check this element first, this element second. Yeah, so in this way we can use the threshold minus yeah, here this m is just the minimum value. It is not this one because it is a function inside. Yeah, we just take a value of threshold. So if threshold minus m more than and equal to 0, I'm gonna update the threshold. Should be, yeah, minus this m. Else I'm gonna return a false because, yeah, it is not possible. Yeah, because if this threshold is too big, this threshold is too small, maybe it is 7, but this is 8, it is not possible, so I'm gonna return false. Yeah, if I didn't return false after executing all the tasks, I'm gonna return a true. Yeah, as you can see, this is the entire code. It is not so difficult, and the binary search part is easy to think about, but this improvement is really difficult. Maybe you can guess about it. Maybe, yeah, you're gonna find some yeah, regular patterns. For example, this is 8 minus 4, the difference is 4, this difference is 2, 4 to 1. Oh, it is decreasing. It means if the difference is bigger, I'm gonna execute the task first. Yeah, this is some pattern. Maybe you don't need the improvement. You can just use the pattern to solve this problem. And then you're gonna check the second one. It is always decreasing. 31, 29, 19, 91. It is always decreasing. So this means, yeah, you can do it according to the biggest gap first, and then the second biggest gap, as you can see. And here also the same. It is decreasing. 22, 20, 17, 16, 12, and 6. According to this, maybe you can also find some pattern without the improvement. You can save time and make it, yeah, make the program right. Maybe you can just guess and try. Yeah. Let me just check what is wrong. Yeah, I forget the k. It should have a k equal to lambda. The result is wrong. This is yeah, I have to debug. Yeah, let me. This means it is a bigger value. Yeah, let me just print out the tasks. Yeah, this means it is right. Yeah, let me just explain this area, so the pattern, because it is always decreasing. This means for the task, you can always check the biggest gap first, and then the second biggest gap, and like this way. Yeah. Yeah, let me just debug about my program. There's something wrong. I guess threshold. The threshold should, yeah, if it is the threshold, if it is more than m, so this means if the threshold is more than m, so what is the result for me? I should minus a, not m, not the threshold. I should minus the actual value because this is according to the description. I forget about it. Yeah, now let me run it. As you can see, it works. Now let me just delete the print and submit it to check if it can pass for all the testing cases. Yeah, as you can see, it passed all the testing cases. The time complexity is n log n. It is about this sort. Yeah. Let me submit it again. Yeah, it is still the same. It is a little bit slow, but I think it is enough to solve this problem, because the time is just less than 1 second. It should be okay. And this length of the tasks is 10 to the power of 5, so it means n log n is enough to solve the problem. Yeah. Thank you for watching. See you next time.